Welcome to this kickoff seminar in the series that I wish to present to all of you, Job Shop Lean versus Toyota Lean. At the outset, I would like to mention that the Toyota production system has inspired me as an industrial engineer. I feel that as an industrial engineer, there is so much that Toyota has demonstrated to me that I could not ignore how much our curriculum and our practices need to be updated. However, what I found after having practiced the Womack Jones thinking, the Toyota best practices, is that once we try to adopt as is the thinking, the best practices that are typically oriented towards low variety, high volume, you will find that when you fit them into the job shop environment, that there are significant limitations. And personally, while waste elimination is definitely a foundation for a successful company, I think that the moment we try to extend or adapt lean for high mix, low volume, we need to have certain capabilities such as flexibility, agility, reconfigurability, and adaptability. I will be discussing and explaining some of these words in a little bit more detail later. But as far as an overview of the seminar goes, I would first like to describe the differences between the Toyota Production System's version of Lean and Job Shop Lean. Next, I will present a modified version of the Womack Jones process. There is a 5-step process. I've essentially adapted that process for high mix, low volume environments. And finally, I'll present a bunch of concepts, technologies, best practices that are relevant for Job Shop Lean, and some of these would be product mix segmentation, mixed mode manufacturing, facility layouts, virtual cells, ERP with fired capacity scheduling, and IT enabled shop floor communications. I am not one to completely embrace a pencil and paper culture. I'm not one to completely embrace a people alone. I feel that people, processes, and systems need to come together to adopt lean to high mix, low volume environments. And most of all, I feel that there needs to be an attitude where we say, look, we are in the 21st century. Let's try and think beyond what we know to work in typical assembly environments. Why? Because so much of the current popular lean best practices pretty much break down once you adopt them into the smaller environments. So let's, against that background, that's what I would like to kind of talk about, that the Toyota production system is kind of unsuitable for job shops. Let's look beyond what we know to exist. So as far as the Toyota production system, these circles that I've drawn will question marks. I have no doubt that regardless of which manufacturing facility you work in to try and improve them, this idea of stability is absolutely important. You need reliable processes, you need stable processes, and of course you have to have this attitude that zero defects is the way to go. So quality is a foundation. However, in most high mix environments, we do not have the benefit of what we call the learning curve, which is that an operator becomes successful when they repeat a task. A machine or equipment or a process is stable when it is run for a long time. Oftentimes when you have short runs, there may not be some of these benefits of process stability, and yet that's what job shops have to do. Kaizen. I do believe that it's a good methodology. I do believe that employees have to take charge in improvements, that we have to have members in a team for continuous improvement drawn from various departments. But sometimes I feel this Kaizen approach is highly limited. I think teams tend to work within the limits of where they work, and so they miss the bigger picture of the improvements they're trying to achieve. Standardized work, again, I think that if you're in a repetitive environment, over time somebody gains the expertise to write down a particular process that they rely on, that they hope will be executed no matter which person is operating a machine. But then if you look at a high mix environment, sometimes just standardizing, even understanding what is repetitive work becomes a challenge. Hijinka, this belief that we can have production smoothing. My understanding of a job shop, my understanding of typical high mix, low volume environments is that you don't have the same products being ordered with a repeating demand. You have heard of terms like runners, repeaters, and strangers. Runners are those products which are always being ordered, there's always a pull, and so you can always plan to have a mixed model production plan, and you make to stock, but then the guarantee is there that there is enough pull from the market to produce those products. So even if you produce them in different proportions, what we call production smoothing, there is a guarantee that the stock is not going to become overproduction waste. In a job shop environment, I do not believe that a job shop has that advantage that for a large proportion of their product mix, the customers are always going to be pulling every week or every month. For a job shop, the product mix consists more of repeaters and strangers. Repeaters are those products which get ordered, but they're not always pulled to a certain consistent Kanban lot size. And strangers are products which don't get ordered. They may get ordered, and at short notice, you would have to have the instruction sheet, equipment capacity, tooling, process sheets, etc. made ready. So just-in-time is good. I think that in a job shop environment, we cannot achieve continuous flow. Most job shops, in the name of flexibility, get organized by process. So they have put their lathes together, they have put their grinding machines together, they have a inspection department. When you're organized by process layout and you don't have manufacturing cells which are stable in the products they make, it is difficult to have this one-piece flow concept. So once again, we cannot take what is clearly achievable in a conveyorized assembly line context and just verbatim drop that into a high mix, low volume job shop environment. So instead of one piece flow, if we can even have small batch flow, that I think is achievable. Takt time. Again, this is coming from the idea of an assembly line, that every station of assembly has a certain amount of time within which they should complete the work in order that the line then produces product at a beat, at a rate that the market pull is working at. Pull system. Typically, if you work with the Kanban, the principle is if you see an empty square or an empty container for a particular type of product, the Kanban, the card indicator on that container or on that space will indicate which particular product has to be replenished in what quantity. But if you don't have repeating demand, just because you shipped a particular container of products does not mean that you should replenish that particular product. So if you look in a job shop environment, there are principles of pull that are more relevant, such as the drum buffer rope principle that theory of constraints adopts, or the constant work in process method, CONWIP, that is discussed in factory physics, or the way finite capacity scheduling works, which is push-pull. They simulate the release of work. They see if this work can be completed. If not, if there are constraint work centers at some of the orders get queued up, pretty much those orders are released in the particular production period. So just in time, the way Toyota adopts it and practices it, in principle, yes, it would apply to the job shop environment, but in terms of specific methods, I think we need to be creative and develop new methods. Jidoka, equipment design, once again, undeniably, that is also relevant in a job shop environment. But then again, there is a tendency to talk about things like right sizing. That means in the high volume, low variety environment, you can go to simplified equipment that is completely dedicated to the particular product or mix of products that it has to process. On the other hand, in the job shop, because they need extreme flexibility, they have a limited pool of workers, there is an extremely opposite strategy, which is have flexible equipment and cross-trained employees so that a high variety of parts can be processed sometimes in a single setup on a particular machine. You do not want in a job shop to have to run short-run orders across multiple machines, because then it becomes costly for you to accept those orders. But from a goal perspective, quality, cost, and delivery, that is a given. You can be any type of manufacturer, high mix, low volume, low mix, high volume, does not matter. You have to have these three capabilities. But as I will mention later, there are some other capabilities that a small manufacturer, medium-sized manufacturer, any machine shop, injection mold shop, tool and die shop, these manufacturers have to have other capabilities for which the standard lean methodologies may not prepare them for. So once again, this is a map that was provided to me by Professor John Yingling at the University of Kentucky, a colleague I respect, system. And why not? Toyota Georgetown is kind of adjacent to Lexington in Kentucky. But again, if you see this particular map, Womack & Jones defined a pretty impressive compact method which basically says define value from the point of view of the customer, then identify your value streams, then within each value stream try to improve the layout, the material handling, the shop floor control to achieve flow. Once the physical facility has been improved, try to institute pull, and then essentially repeat this process in a continuous flow, continuous improvement methodology. But again, you can see that if this is the map of best practices, these circles that I've drawn again with the question marks, these are where I feel that it is countered in a job shop to adopt some of these best practices. And I feel that there are easily alternative methodologies which would replace some of these best practices. So in conclusion, the Toyota Production System, classical lean methodologies, they're absolutely necessary no matter which company you work with. The lean thinking process of Womack & Jones, that is a given, it's a proven methodology. But the specifics of implementing these best practices, those are what Job Shop Lean tries to encourage people to think fresh about, to think beyond what Toyota has to offer us. So let me give you some of the key differences of job shops, at least the way I understand it. Of course, this first difference is from something which the speaker himself wrote. But, well, sometimes you have to quote yourself to justify certain points of view. Primarily in most job shops, they are organized by process. And why? Because they think they need to be flexible. Why do they need to be flexible? Because, in many cases, they may make anywhere from 100 to 5,000 different part numbers. Or in worst cases, they may be custom manufacturers of complex products. Now, if you understand that a particular product has a routing, then in the principle of a value stream, this is the challenge, that if you feel that a product family is like or analogous to a value stream, well, in a job shop, trying to break down the product mix into several distinct families, where inside a family most of the products could be made with the same manufacturing routing, or at least using one or other combination of the equipment put together in a cell, is not exactly easy. So that's the first difference. That is a pretty high mix facility, unlike the typical assembly line or top tier manufacturer, where they can afford to dedicate their equipment to certain product types or very defined families of products. Next, the next difference. Most job shops are organized by process, which means that they have their lathe together, their machines together, inspection department. That's called a process layout. Well, this book has an extremely nice paragraph where, being good consultants, have essentially empirically said that when two process steps are adjacent to each other, you get what is called one-piece flow. Guess where this comes from? This comes from the assembly line. You have a certain paced, synchronized flow of product, and the workstations are next to each other, and pretty much each workstation does a certain type of activity only, no matter what car or vehicle goes past it. Now, from the point where you have two adjacent processes, supposing you put two processes just across from each other from an aisle, a material handling aisle, which is about, say, 14 to 18 feet, automatically the operator of one machine cannot make one part and quickly transfer it across the aisle to the next part. So they tend to batch. and that batch, in the case where the separation is across about 15 feet, is a unit load. That creates work in process waste. Now, in the process layout, if you put two consecutive process steps at two ends of the facility, the amount of inventory which tends to buffer between these two work centers increases. So the work in process automatically increases the moment that the distance of separation between consecutive operations in any product's manufacturing routing exceeds adjacencies. Now, if you put those two consecutive process steps in two different buildings, then you start buffering even further. So in a typical job shop, it can be taken for granted that if you have a process layout, they are clearly far from lean. And so transitioning from a process layout to a cellular layout, where each cell is a combination of dissimilar equipment and each cell is capable of producing a family of parts, that transition is not that easy. Why? Because many times the product mix itself cannot be completely separated into families, and then given the expenditure involved in trying to buy enough equipment so that each cell becomes independent is usually humongous, and people start saying, well, we need to share resources between cells. So the moment you transition from a process layout to a cell layout, it is not a trivial problem to do the conversion. So that's the second difference. Here are some more differences. First, extreme volatility in incoming order demand. That's typically what the high mix end faces. They have few customers who have them on a long-term agreement for certain parts which are on a Kanban pull. Most of the time, the due dates get jerked around. Most of the time, the order quantities get jerked around. In some cases, orders get cancelled. New orders get inserted. So there's extreme volatility. So the typical job shop environment does not have one of the benefits that, say, a Honda or a Toyota have, which is that they have some knowledge, some reliability and predictability about the demand that the market will impose. Next, most job shops make a high variety of parts. I know of a transmission manufacturer, about 14 million in sales, where they claim that they had on file about 1,500 different transmissions. And every customer claimed to kind of come in and give them a different design. So in a job shop environment, we have a certain diversity of product mix and variations of part compositions of various bills of materials that's far in excess of what the typical vehicle assembly plant has to worry about. Next, when you're in assembly, you pretty much have your standardized setup times, you pretty much have a standardized process time. Now, if you go to a job shop, you're going to find a lot of products which have significant variance in setup times between operations, between part numbers. They'll have significant variation in cycle times, and then the lot sizes will also be different. So even if you had a linear job shop, and that is called a flow shop, it is not a trivial problem to try and operate and schedule that flow shop as if it were a mixed model assembly line. A mixed model assembly line is not equivalent to a flow shop, and a flow shop is a relatively simpler version of a job shop. Another difference, it is hard to segment most product mixes of job shops into clear-cut part families or segments. I will give you criteria on which we plan segmentation. It's a simple alphabet sequence. It's called PQRST. P stands for the product mix, Q stands for volume, R stands for routing, S is actually the dollar sign, stands for sales or revenue, and T is demand stability. So you already have four criteria: volume, profit margin or sales, demand stability, and whether or not the product fits into a clearly defined family. If you tried segmenting all of your products into multiple classes, say high mix, low volume part family, or short run prototype part family, it is not a trivial problem, and that is the challenge that most job shops face. How should we organize our business into one or more segments? Next, if you look at the typical implementation, most companies have gone through the pain and hardship of completely reorganizing their existing layout. They have converted in most cases to focus factories, dedicated lines, or cells. And most of these cells I would call as low variety, high volume. Well, guess what? Given the variety of manufacturing routings, at least in the job shops that I have worked with, it is hard for us to go and pick up any textbook and say, you know what, I think that this facility should have a pure cellular layout. Let's organize completely into 10 cells. If from a business perspective, you take a decision to only accept business that belongs or will fit into at least one of your existing cells, then by all means convert to a cellular layout. But if you wish to be quick response, if you wish to be providing short run orders to customers, why? Because you're able to price appropriately to make money on the short runs, then I think it's important that you think of what I call mixed mode manufacturing layouts. So under the same roof, you might have certain dedicated cells which run a certain number of parts with a long-term agreement. You may have some flexible cells which are almost like job shops, but they're capable of producing a family of parts. And then you may have a third area, what I would call the job shop portion, where you would run really short runs and might have extremely flexible equipment, extremely capable people. So it is difficult to adopt the best practices of the Toyota system, where they have gone to focus factories and linear or U-shaped cells, because they can provide stability to those cells. In a high mix environment, I think you have to be non-traditional in the way you organize the physical assets. So many companies, they go to architects and they get a blueprint, and little effort was put in to do a production flow analysis to understand the various segments, to understand best hybrid layout that would fit the production flows. And as a result, most job shops are from the outset handicapped. Another difference, wide customer base. When you have a wide customer base, you have demand lot sizes which will change, due dates which will change, and schedules will be jerked around according to the women fancy. So once again, in a job shop lean environment, I think we need very strong scheduling capability, very flexible shop floor control. And that's somewhat like the assembly line environment, where schedules, demand lot sizes, and due dates are pretty much known, or they don't matter. I mean, if you're making to stock, there is no issue of a due date. You pretty much look at the on-hand inventory of particular products and appropriately send a pull to replenish the inventory for those particular products. Another big difference in most small companies, we have big companies, who can afford senseis and they can afford full-time employees. My experience in most job shops has been that they have limited resources to commit to full-time training and deployment. I don't think that you can become lean and stay lean if all you rely on are outside experts, so-called outside experts. You have to develop the in-house capability, from the owner of the shop right down to the machine operator and the material handler. Somewhere or the other, you need the understanding of lean in a job shop context. Personally, I feel in the 10 million sales per year job shop is losing enough money, and they can afford to hire one industrial engineer from any recognized program. At the same time, let's keep in mind that these small manufacturers do not have the benefit of the typical Toyota or Honda to have large analysis groups running simulations or conducting time studies, because that's the nature of the beast. They are small. Another difference, you cannot use pull scheduling the way it is operated at Toyota or Honda or Ford or GM. And that production control scheduling model simply does not fit a job shop environment. Let's take shop floor control. Yes, supermarkets, which are short-term warehouses, do work in some situations, but most supermarkets are designed by product number. In a job shop environment, when you have a constrained machine, you may not have the same products always accessing a particular work center to be worked upon. So in that case, if you have a time buffer of, say, an 8-hour shift, you have to have the ability on some days to run just 2 orders to fill that capacity, and on some other days you may need 10 orders to fill that same capacity. So shop floor control and scheduling and production control are a different monster. once you end up doing job shop lean. Finally, the difference, and I'm sure there are other differences that I may have forgotten, it is sometimes hard to standardize work processes. It is hard to kind of corral certain people's thinking. I think in most jobs, people are proud that they're able to do hit and trial, they're able to make a few bad parts, then they learn to make the part correctly. But that is the challenge of a high mix, low volume environment where a lot of people might feel, well, we're not able to standardize our processes and therefore it's okay to make bad parts. I think that's wrong. But that's again the challenge, and that's why again I feel that there is a difference between Toyota Lean and Job Shop Lean. So, I read the classical process of work, figure it out, or they have a basic process which is define value from the point of view of the first step, identify the value streams, then institute flow inside the value stream, then schedule for pull, and then essentially you kind of follow like a Six Sigma or whatever process improvement where you go from one value stream to the other. So this basic thought process and implementation process is correct, but now let us look at some differences. Quality, cost and delivery, as far as defining value from the point of view of the customer, is agreeable. I mean, just about any job shop also has to be like Toyota. But then I think the typical job shop has to worry about flexibility, the ability to be able to run different mixes of parts in any given shift or a week. They have to have the ability to reconfigure. If business changes, if volume changes, if technology changes, somehow their shops also have to be reconfigurable. They have to be agile, the ability to quickly change over equipment, layouts, support systems, anything as far as quick response. And then adaptability. Most shops may not have the ability to demand a certain delivery quantity and quality, say of bar stock. Sometimes the steel mills might say, hey, we gave you some bar stock with bad quality, that's your problem. So depending on the quality of incoming raw material, the job shop owner and his shop have to essentially adapt their processes. So these are some extra demands that the first step, define value from the point of view of the customer, is what the job shop has to be able to do. Next, value stream analysis. I think the job shop situation challenge becomes, what is a value stream? Now, if I were to understand that every product or part which has a manufacturing routing could constitute a value stream. Why? Because when you sell that particular component or product to a customer, you make some money. But then if you have 1,000 value streams, the biggest challenge is how to identify the families of parts where each family of parts could kind of approximate a value stream. So in some situations, you need to pick a sample of parts. I mean, if you're making 5,000 different part numbers, you can't just go and map each and every part number. You can't walk through the facility and trace the routing of each of those 5,000 part numbers. So you apply some 80-20 rule. But again, in a job shop, you can't just segment and pick the sample of products based only on volume. Sometimes you have to look at profitability. Sometimes you have to look at demand stability. You have to see if those parts belong in families. Go back to the method I talked about, PQRST. And then, of course, you need to go and form part families. FAST is a piece of software that we have developed at Ohio State University. It has always been successful in taking a large product mix and bringing it down into part families. Next, rethinking. Let's look at flow. Quite often, and I've been kind of working with forge shops, so that's some of the most difficult environments to cellularize. Cellular layout is often not possible because you don't have the asset base to create independent cells. So once you have intercells and once you have external monuments, you have to develop what are called hybrid layouts. In some cases, you may have to implement virtual cells. A virtual cells is simply where in a process layout, in each department, lathe, mill, drill, grind, you designate a particular piece of equipment and dedicate its tooling and setup to a particular family of parts. So even though the individual pieces of equipment have not been co-located into one area, which would be a physical cell, in setup and process capability, these individual machines are prepared to run particular parts. So that way you minimize the changeover losses if the same machine were running parts which are very dissimilar in their setups. Then you need a lot more shop floor control. So once you have external monuments, putting work from cells to these shared monuments and then sending the work back to the cells so they can complete what they are doing by due dates becomes a challenge. You can do these with lights, you can do these with Kanban cards, you can do this with water striders, material handlers who have some awareness of scheduling. You can do this with scheduling systems. The idea is that you cannot achieve flow in a job shop using standard methodology that the Toyota production system has mastered. Finally, pull. Again, here you're familiar with the theory of constraints. So what they would say is that most shop floors have certain equipment as constraints. So when you have a family of parts which you're calling a value network, the scheduling you would do is based on what the capacity constraint work centers are able to do, not what the non-constraints are able to do. And then you have to have some form of work order release. You have to have some form of WIP awareness, so that at any point in the shop, the material handlers, the people who operate the saws, the lead off, the primary machines, the supervisors, the plant managers, what they're always saying is, look, as far as I'm concerned, if the constraint work centers have more work they can accept, do not release new work into the system. So then there is a need for non-term methods for pull, push-pull, constant work process, finite capacity scheduling. So the idea of lean rethinking is that there are methods, there are thought processes, there are concepts outside of what Toyota has taught us that start playing a role the moment you start to implement in a job shop environment. This map is, in my opinion, it contains some of the best practices identified that look beyond what the production system has taught me. So let me start with things that I think job shops either should master. I mean, there might be some best practices that Toyota has already taught us, but then there may be best practices that in the 21st century we may need to master and evaluate as to their relevance and success in high mix, low volume environments. So the first thing, waste elimination becomes a religion for everybody. Absolutely. You cannot have a situation where the president says, well, I read the goal and give me some lean, The president has to understand lean the way it would have to be implemented in his or her high mix, low volume environment. Every operator has to be able to look at their work. It cannot be, well, I'm paid by the hour, so I'll keep busy producing parts that unfortunately will become inventory, which will go into queue at the next work center, or I'm going to take these parts I make and put them into a rack. Waste elimination is like a foundation. 7 types of waste essentially add to cost. They essentially add to flow delays. And so everybody, even in a small shop, has to understand waste elimination is an absolute must. Next, variety reduction. What is variety? I mean, how do you say that this particular part which I'm making is different from the other part? Do these parts differ in routing? Do they differ in their materials, in their due dates, in their tooling, in their fixturing? Somewhere you have to reduce the variety, because if you do not reduce the variety, you're going to be forced with the need to become flexible and agile. And it's not exactly cheap to be flexible and agile. So as much as possible, the job shops have to start looking at the work that they do to produce different parts and start thinking, hey, can I do group technology? Can I use one process to make a family of parts? Do I need these many tools? Do I need these many tolerances on the parts I make? Do I need to have so many material diameters? Reduce the variety. Because if you plan around manageable variety, yes, you can adopt in a job shop. Product mix segmentation. There will be a separate seminar in the future where I will teach these methods, but The idea is that every segment of your product mix ought to be produced in a different portion of the facility. That has to do with this idea of mixed mode manufacturing, mixed mode factories. There are challenges, but the idea is, let's just take two criteria on the basis of which we might define different segments of the product mix. Let's take volume, and let's take, say, either sales dollars or profit margin dollars. So you can have a two-axis system. On one axis you would plot volume, on the other axis you would plot sales. So volume could be low or high, that means there are two levels. Sales could be low or high, two levels. 2 times 2 is 4. So essentially what you have is low volume, low value, high volume, low value, low volume, high value, and high value, high volume. So if you have 4 segments, and it is not a trivial matter to make the same facility, especially if you're a small manufacturer, cater to 4 segments. And we haven't even looked at routing families, we haven't even looked at demand stability during our segmentation. So this is not a trivial problem, but I feel that more than doing 5S or SMED and some of these easy improvement strategies, most job shops should look at their business and they should work with segmenting. I mean, you've heard of runners, repeaters, and strangers. If you find that a lot of your business consists of strangers, you really have to go through a business rationalization process every year and start saying, really want to be making these part numbers, or can I pretty much discard them, or better, send them to my competitors so that those competitors get screwed trying to make short runs on difficult parts. Value network mapping. Just as value mapping is extremely effective for high volume production of one or few products, similarly, when you try to produce a complicated product, as in a make-to-order situation, or you're trying to produce a family of parts, then when you have merged together the value streams of a large number of parts, you get what is called a network. A network essentially is a coming together of multiple linear streams. Part family based planning, but of course, my bias is that if you want to design flexible cells, if you make sure that you buy multifunction equipment that is capable of combining appropriate combinations of work centers, then planning part families, and then the technology you buy, the cells that you create, they have to be flexible. So these group technology, product flow analysis, these are the methods that you would use to essentially do part family based thinking. And again, planning would mean that all the processes, all the front office processes, all the 5S activities, all the fixturing, everything, all the planning that you do, you kind of work around part families. So that means inside the part family, you do not wish to see too much variation that is unnecessary. Mixed mode, again, I've probably said that to you, that I think that most job shops should at least think about having 2 businesses under one roof. If you share too much equipment across these 2 areas, that basically reduces to a process layout, and no process layout with its batch and queue mode of operation has been known to be profitable. So that's the best practice that I think job shops should think about. Virtual cells, the idea is that if you have an extremely dynamic product mix, then the material handlers could become cell managers. So these cell managers, there's a person called a water strider that Toyota uses, an extremely skilled person that is able to move around different portions of the facility, supporting people working in those areas. I think that material handlers ought to be skilled people, not paid people. I think that the material handler with scheduling knowledge, with lean knowledge, with theory of constraint knowledge, could become the cell manager on. That means he or she is running around the shop, working with those groups of work centers that together are able to make families of parts. The idea of the virtual cell is essentially that you haven't physically figured into cells, so even if the mix and volume change, you don't have to pay the cost of physically routing equipment and moving it around. Job bartering among competitors, again, I think in the job shop situation, a lot of manufacturers tend to take whatever business, or at least, not that they are just random or wanton in the way they accept business, but they still tend to have an extremely high variety of work that they accept. Is a possibility that we could use tools like FAST or group technology, and competitors could potentially swap work across from each other, so that even though a particular manufacturer may have accepted some work, because there's a bad fit, they might have some other competitor who has a better fit for those jobs to their facility. So the idea is that, again, even with a job shop, if they could focus to some extent their core competencies, if they could plan around a reasonable number of part families and not just accept work just because they have certain capabilities, that bartering, that ability to swap work between seems to be an opportunity. Enterprise resource planning with finite capacity schedule and shop floor control, expensive system. Again, I've seen small companies buy SAP. I know that SAP sometimes stops all production, not a very complimentary acronym, but if you're buying ERP and that ERP has a glorified material requirements planning with unit loading capability, you're hurting yourself from the outset. I think what most shops need is finite capacity scheduling modules inside of the ERP system, and they need equipment level knowledge they can manage available capacity. Multi-skilled force. I think most job shops do have it. Their operators are pretty good, but they also should IT savvy. They should not worry about having to deal with computer interfaces. I had a case where this idea did not work out. The machine shop was moving to a new facility, so they contacted me and they said, we would like to have a new layout. And I found from their product mix clearly two families of parts. But guess what? Their plant manager and employees were not comfortable going to a cell mode because they felt they were more skilled at running their particular machines. So even though a change of facility is appropriate for converting a facility into flexible configurations, if your employees aren't ready to go into multi-skill, multi-machining mode, there is no way that you would want to do the transition. So the owner of the company pretty much said, you've made me think about what I will in the future, but right now, when I don't have much time to cross-train, where our employees are mainly capable of operating particular machines, they are not comfortable, the plant manager is more comfortable working in a process layout, we put back our equipment into process groups. IT-enabled shop floor communications. Look, if everyone is using cell phones, why can't we have family calling plans where material handlers, supervisors, plant managers, constraint machine operators are in real time connected to each other? Why do we rely on public address systems? Why do we rely on material handlers pushing work into work center queues as a basis for job shop control? So I believe that shop floor communications has to leverage IT, the way IT is being leveraged in the service industry. Process standardization, absolute must again. It's nice to have production on a particular part number, but then once you have a diversity of parts, what is called a standard process? How do you flex a particular process to adapt it for multiple part numbers being run on the same machine? Self-informing workplace, again, ID, network of cameras and constrained work centers. I know of a company that implemented tier of constraints by putting a web camera on their constrained machine. Clearly they knew what was the work in queue. So even remotely the production controller was able to look at the existing work in queue and appropriate call out by email or phone to the raw folks, the saw operators or the forging people, to release new orders based on his estimate. If they released orders at a certain point in time, the available space in the time buffer in front of a constrained work center could be filled up. So as much as possible, you would like to know where work is. You don't want to have a situation where people are walking around a facility trying to locate orders. One shop in Gahana, one day I saw the president around the shipping and I asked my guide, who was the manager, what's the gentleman doing? He's like, he's checking up on a partner. The customer must have called in, screamed at him, so now he's walking around the place trying to find where the part is. Imagine, this is the owner of the company. I mean, his time may be worth $200 an hour. And what is he doing? Trying to go through a disorganized shipping department area to find a particular part or a particular container. This ship, 4 H's. I know you don't want to be called a horse. I mean, no president would like to be called a horse. But, you know, it's not very sexy. People talk of 5S and 3P and 7Q to say 3 H's and 1 leg, you know, and 1 legs. What I mean is that in a job shop, the adoption and sustainment of lean best practice is going to come from the leader. It's the president, the vice president of operations. You know, the leadership really understand from a people perspective to inspire their employees. So head, I mean, you should know, the guy should be smart, you know. They should understand, they should understand the ramifications of high mix, low volume. Heart, they should have the courage. They should have the humanity. You know, if certain members are learning and they make a mistake, you can't holler at them the first time they make a mistake. So there has to be some humanity and courage. Hands, again, get out on the shop floor. See people working for yourself, you know, shake with people, appreciate the work that they do. And again, who? Get out there. You don't go to a breakfast meeting with other peers, other owners, you know, and you discuss high level, oh, the gold, very good, oh, lean thinking, oh, the gold mine. Hell no. I mean, you have to really walk the talk. You know, this idea of standing on the X, look up, the idea of the facility walkthrough that owner and his sensei subordinates taught me, wonderful. I cannot tell you how much that is valuable. Risk management, uncertainty. Again, since shops have to worry about their customers pretty much taking business elsewhere, usually say to overseas suppliers, you have to be planning for, you know, you have to be looking at the standard individual classification, SIC codes, and saying, well, if I lost business from this particular customer, what are other SIC codes, which other companies in my neck of woods or abroad would I be able to supply? Because pretty much with this equipment and technology, I'll be able to make other parts which are similar to the part I lose. So planning for variance or variability, Six Sigma, would teach us. Risk management is important for the job shop owner. And finally, distributed and or co-located teams. I mean, if IT sector, people are moving work between America and India, I can't see why we can't have design teams and machine operators in the same facility to work with each other. And this goes back, this idea of business and co-location goes back to ideas like virtual cells, flexible cells. My belief is that job shops should work around part families. Now, when you bring equipment together and create a physical art, the foundation for job shop lean is your knowledge of part families. That's so. This whole slide is giving you my humble view of what are things that we learn beyond what Toyota has taught us. There's so much that I think Toyota have to offer to the high mix, low volume manufacturers, and they, I think, are the next frontier. Well, methodology. Again, this is a complete methodology. It intimidates a lot of people, but the idea is that this is essentially an extension of the basic thought process that Womack Jones described in lean thinking. So you start here with segmentation, PQRS analysis. Once you form your part families, you pick a part family, that's your value stream. Then you map the assets. You create the network map, you do flow process charts, spaghetti diagrams, 7 types of, you walk around the facility. This is all basic, fundamental, sound industrial engineering. I'm not saying anything that industrial engineers among you won't understand, but the idea is that there's a lot of value in the simple stuff. Waste elimination, looking at spaghetti diagrams, trying to break down the work you do into value adding, necessary but not value adding, and non-value adding activities. This step is important. And the good thing about working with the part family is that any improvements you make should be flexible. But if a particular improvement strategy works, then you can multiply the cost reductions. Why? Because that particular improvement is applied to a bunch of parts. So I think the part family concept is extremely strong. Okay, so once you've developed the value network map for the part family, then you apply theory of constraints and you go and work on the constraint machines first. Don't do 5S across all the machines, don't do SMED on all the machines. Try and work with those constraint work centers. This is called exploit or elevate the bottleneck. All of this has to do with capacity gain. You know, so many companies say, well, we work 8 hours in a shift. Well, take away 30 minutes for breaks. That should give you about 7.5 hours of available capacity. Well, guess what? If you applied all these improvement methods, Toolkit, Six Sigma, you would find that of that 7.5 hours, maybe 4 hours, 4.5 hours of available capacity is being used. So, theory of constraints is as much a part of lean thinking for a job shop. You know, I don't say that lean alone is the way to go, but this process where you focus your improvements on constraint work centers is extremely useful. Then of course, you know, once you have the cell, it's like a job shop. So then personally, you know, because we come from the academic environment, we have formed some of these tools, software tools, to help us to actually fine-tune the performance of the cell. Could be anything from sequence in which to run jobs, to number of operators, to number of machines, whatever. Once you have optimized this particular value network, then you essentially go and do subordinates. So that means now you look at the other equipment in the cell. You look at support systems. That's the theory of constraints again at work, you know. So always you are focusing on a family of parts, you're focusing on constraint work centers, you're focusing on the manufacturing cell within which the constraint lies, but you're always going in terms of next level of improvement. And I think theory of constraints has a very good thought process that belongs or blends very well with lean. Now once you've done one part family, then you say, are there part families? No, then you know, you go back and pick another part family. So you can see that my bias remains that you either create flow line like cells or you create flexible cells, and then as much as possible reduce your existing job shop to this one area where you really are a job shop, meaning that there are no due dates, there are no part families, there are short runs, sometimes prototypes. So this is the detailed methodology. In a future seminar, teaching a quick start methodology which kind of simplifies this exhaustive method. It gets management fired up that yeah, they want to adopt the whole comprehensive method. But that's essentially, I give credit to Womack and Jones. You know, they have a lean thinking process, 5 steps. I've essentially just broadened up that method and brought in computer-aided methods to attack some of the harder problems. That's all. I've essentially put together Six Sigma, lean, theory of constraints. Everything belongs together. I don't feel job shop should kind of go under one umbrella and say only do lean, or we'll only do theory of constraints, or we'll only do Six Sigma. Use whatever works. That's the job shop methodology. Again, people have accused me of being a software freak. I feel that there are a lot of problems with job shop lean that simply absolutely could not be solved by hand, period. And so this portion of the implementation process uses software called FAST. Please, in this acronym, the P is silent for obvious reasons. It's pronounced FAST, but it stands for Production, Flow, Analysis, and Simplification Toolkit. I'm firmly convinced that if you do not simplify your job shop, you ought not to step into things like finite capacity scheduling. You ought not to be doing 5S and SMED as the first process. Simplify the flow of the shop. And what's the best simplification? Just as in a Toyota factory, things move along a line. Could you take these multiple routings? Could you arrange your shop in such a way that pretty much any product that you make goes from one location, receiving, to the other location, shipping, as much as possible in a line? So there is a factory layout called hybrid flow shop. That pretty much is this flexible linear arrangement that you have for your assets. Then once you've defined your cells, I recommend tools like simulation. And then finally, when you're trying to execute on a day-by-day basis and you're managing dynamic constraints, job conditions, volume changes, machine breakdowns, then you bring in the finite capacity scheduling. So factory design tool, performance evaluation tool, and then day-to-day scheduling tool. That I believe maybe individual shops may not be prepared to buy these software packages, but if they were creative IT providers, what could do is create portals and then allow these small manufacturers to access these deposit or collections of tools. Again, I'm not saying that common sense and simple methods will not work in the job shop lean methodology, the framework. Also found numerous problems that simply cannot be done by pencil and paper methods. So once again, my advice is always, look, if the simple methods work, yes, but if the problems are difficult and require slightly more involved tools to be used, then by golly, please go and use them. I mean, today we talk of things like PLM software, product lifecycle management. We talk of product configurators, like there's a company called Sim in Cincinnati. Look, even the small manufacturers need these capabilities. It's just that they can't afford it. But you can't just say that in a high mix, low volume environment, you don't need capabilities to handle thousands of different designs, thousands of different toolkits. So there is a software element to the job shop lean methodology, but I'm in no position to demand that you adopt software all the time. It's a software, again the P is silent, and these are again, once the outputs come out, I essentially go back and implement the whole job shop lean methodology. But the idea is that if you gave me a meaning, if you gave me your routings for all your parts, if you gave me the annual volume and revenue for each part, and you gave me the work center list and plant layout, then simplifying your flow is where I would always start. And from that simplification goal, there are numerous improvements which you can make. So my bias remains that job shop lean simply means simplify your shop, simplify your business before you adopt some of the known Toyota Production System best practices like 5S or SMID or visual displays or Kanban. This entire program has been funded by the Defense Logistics Agency. It began work in 2001, and our charter has been that we should, through the Forging Defense Consortium managed by Advanced Technology Institute, our charter has been to essentially provide lean capability to custom forge shops. These are shops that provide forgings in small quantities to the DoD and DLA, Department of Defense, Defense Logistics Agency. Why? Because they maintain weapon systems which aren't exactly in big numbers. So, you know, the whole idea of short-run production and the success of lean inspired by Toyota's production system kind of made me propose to this team, and they funded my proposal thereafter, that okay, go ahead and develop this whole job shop lean methodology. Thank you very much. At this point, if there are questions, I would welcome them. Next week we will be having, 2 weeks from now, we'll be having the next seminar, which will be a quick start approach to job shop lean.